I would like to introduce now Markus Fischer, who's the mastermind of ITRPV. Really, as I mentioned, the compass to the technical developments in the solar sector. It helps us a lot showing where we are heading, and Markus comes originally from Q-Cells, where he's heading R&D in Germany. Markus, the floor is yours.
Yes, hello, thank you very much. So I try to start to share my screen. Yeah, okay. So now, can you see it?
Yep.
So video sharing obviously does not work. So don't know. Ah, no. Yeah, okay. Now, have some. So okay, let's start. So ITRPV 13th edition. Thank you very much for this kind introduction. So I will here show the report contents and focus a little bit on products. So as you here will introduce or will discuss, especially Intersolar Munich findings. So this is my agenda. First, I give a status on the ITRPV and the learning curve. You just showed it, and then I will show here the results of the ITRPV for the different subjects and close with a brief summary. So ITRPV status. So this year's edition, it is now the 13th edition that we have. It shows. Okay. So now it works. Okay. Okay, so now in the 13th edition, we summarized overall 81 figures with, that describes more than 100 parameters, and 62 contributors from Asia, Europe, and US contributed to this year's 13th edition. And we cover here the whole value chain, starting from silicon up to downstream to system, and with focuses on materials, processes, and products. So here, the learning curve. Yeah, so shipments last year were calculated by us to 183 gigawatt. And interesting here, the price we calculated is $24 per watt peak. So first time since several years, an increase in price. Yeah, so we had this year in the 2005 to 2006 phase. So, and with the overall shipments, we were close to the 1 terawatt. So you mentioned here in March, April, we expect that the 1 terawatt was reached. So learning rate overall from 1976 to December 21, 24.1, and if you consider here this time frame from 2006 to 21, so it's close to 40%. So there was, despite COVID, a significant increase in shipment, and important to emphasize here, change in module size continued. And what is new here, price increase is significant, and so we will expect this for the next years as well. So we have to accept further burden to increase logistic costs. So how was the pricing calculated for the last year? And so we took here the product share of the different products that are in the market. So most of the products are mono-based, and silicon mono standard. So this is $0.24. So then there is still multi in the market. So $22. And then we have special products that do not show such a higher margin than in the past. And so we came to this $0.24. And what you see here, due to the shortage in silicon, so the share of silicon increased, and this makes all the value chain quite sensitive. And
Markus, sorry for interruption. I think some people commented that it's that they cannot hear you so well. Can you maybe
okay,
make it a little bit louder on your?
Okay, so I have here my speaker on. Yeah, so is it better now? Is it better now?
Yeah.
Hello? Yeah?
Yeah.
So I will speak louder. Yeah. Okay, so what we see here, so what was mentioned here, the big cost adders due to skyrocketing logistic fees since Q1 21. So it is tenfold and even 12-fold increase, and this we have to compensate here by efficient logistic systems, and here by this optimized cost structures. So now to the results. So first of all, let's start here with silicon. And this year we first time calculated or reported not only the price or the polysilicon consumption per wafer, but also per watt peak. Yeah, and there we see that we have here an average consumption for this M6 and M10 wafers of 2.2 grams per watt, and on cell level. And we see that for this G12 format, it is slightly higher. So this was surprising. And this means that we have for the future to watch this, figures very sensitive, because this will also decide on the real efficiency of the format this is chosen. And so we see that M6, M10 is quite optimum. So here for the market share of different wafer types, what we see in the market. So for the material, we see that mono is dominating, and P-type mono is dominating here the market. And for the years to come, we see that N-type is gaining market share. And there is still some multicrystalline product in the market. So we saw it also at Intersolar that there are still some products available. So P-type got a further boost by introducing this gallium doping. So now you only have gallium doping in the market for P-type. So, and for the formats, we see that this small formats are nearly disappeared. So we have G1 and M4 still as transition format. It's still in the market, and is expected to disappear soon. M6 is also is currently quite common in the market, and also M10 and M12 are introduced, and this share will increase. So this is what we expect. And new fabs will require the new tools, and there it is easy that they will handle this M10 and M12 format. So then let's come to the cell technologies. It was also shown at the Intersolar. So that the workhorse currently is this technology with diffused PN junction. So PERC and TOPCon concepts are the workhorse. So we see also for the future that heterojunction is not taking over the market, but will increase the share with up to 20% within the next 10 years. So IBC still a niche. And what we see here, what we found, that tandem is expected to appear from 2025 onwards. This is quite important message. BSF is about to disappear completely. So, and to have a further look on this technologies with diffused junction, this diffused PN junction. So we see that mono-PERC is currently the working horse, and passivated contact cell concepts on N-type mono are expected to gain market share. And what is important for this technology, so also heterojunction is bifacial capability. So in there we see that the share of bifacial cells is increasing, and this is also the case for the bifacial modules, but bifacial cells can be used in both type of modules. So this share here is the share of bifacial cells in monofacial modules. So dual use is possible. This is quite important. So regarding the metallization, so it was...
Markus, once again, please closer to the mic. So I think there were a few comments. If you get the microphone close.
I put out now my my headphone. Is it better now?
Yeah.
Okay, so maybe that my headphone has a problem. So my headset. So now let's look here to the silicon to the silver consumption. So this is quite important. So it is discussed often in the community that we will have here problems with silver consumption. So and therefore in this edition we reported here silver consumption per watt, so milligrams per watt. So in this scale you can take one by one 2 tons per gigawatt, and so we can calculate. So that with the expected volume of 250 gigawatt, we will consume about 3,000 tons, and this is about 9% of the annual silver consumption in 2021. So don't worry, and we will expect. So even if this is increasing to 1 terawatt, so it can be handled. So we had similar situations in the 80 years of the last century. So a lot of people forget this. So this was consumed by photography. So don't worry. So comments from the past also predicted that silver will not be enough for the industry. So this will not be the limiter. But we have to take here care, especially regarding this N-type and the N-type concepts. So they currently consume more silver, and this has to be reduced in the next years. So now, what measures we have here to optimize the silver consumption? So think of it is reduced, and this means increasing number of bus bars. So the small bus bar numbers, 5, 6 bus bar, are about to disappear. Nevertheless, we found something at the Intersolar. So 9 to 10 are also reduced in the market share, but 11, 12, and even multi-bus bar and bus bar less is appearing. So this we saw at the Intersolar as well. So and here now this leads me to the efficiency outlook. So this is what we find here. Current mainstream is for PERC is 23.2% in the market. Heterojunction is leading the crowd here with 24%, and we expect this efficiencies to increase over the next years. Prediction by the ITRPV was a little bit conservative, but we see what we find here, that we will come to the practical limit of the efficiency, and therefore we expect that tandem will overcome this limitation with efficiencies of about 27% in 2026. So for modules, so it was discussed here in the sessions before. Copper wires are currently the main technology. Still ribbons are available in the market, and this copper wire are using lead containing soldering. Nevertheless, there was also showed in the at Intersolar some ECA approaches and lead-free soldering, especially for heterojunctions. This is required here, and we see that this technology is gaining market share. So ECA and lead-free will also appear more and more in the future. So regarding the cell form factors, half cell are currently dominating, but we also found here, especially for the large wafers, this is what we see, third and quarter cells. And so 1/3 cut G12 M10 module products were shown. And here, especially regarding the formats, there are a lot of different formats appearing. And the former mainstream 120 half cell and 144 half cell still in the market, but other formats are gaining share. So this leads me here now to an important parameter that we have here. So this is the module efficiency. So in the past, we only compared this, the module power for this 120 and 144 modules, but this is now not any more a measure of performance. So we have to focus. We think that focusing on module efficiency is quite better, and so we see here that current products are around between 21 and 22% efficiency, and so we see that this module efficiencies will also lead here over the next year to 24% module efficiencies. But with tandem, we expect here to go beyond this practical limit of 24-25%, with up to 26 in 2026. So this leads me now here to the different formats. So there was also yesterday some discussion about these different formats. Especially important for me to emphasize is the requirements for rooftop. So we have here the mainstream between 1.8 square meter and up to 2 square meter. So this is a limit also for handling this on the roofs. This is important to consider. And for this power plant application, we see that up to 3 square meter are standard. And it was also discussed yesterday that we need their standardization. So this is quite important. Also, not for the power plants to standardize here and to really benefit for the LCOE advantages. And we have also to consider here, especially the high weight. And yesterday in the discussion you mentioned, we will see how this heavy modules will be handled. New formats appeared. So there were Intersolar also some tile solutions. So for rooftops, so I think it's expensive solution, but it will be a new niche. Okay. So here in the Intersolar, we saw the first products that appeared with 1% degradation in the first year and 30 years product warranty. So current mainstream is 2%. Annual first year warranty, first year degradation, and this will come standard in the next years. And performance warranty so far also 25 years, but the 30 years that appeared for the first product will be appearing for the next years as well as standard. So, and how we ensure this high quality requirements. So it will be ensured by this inspection systems in the factory. So EL inspection is standard in module production. Automatic optical inspections are also standard in cell and module production, and fab automation will hedge finally the high quality of the PV product that we need for the terawatt era. And now here a brief look at the LCOE. Michael, you mentioned this. So PV is now the cheapest power we can generate and we can use. And the trend is that this LCOE will even decrease over the next years. And even in Europe, we found here projects with about $3 per kilowatt hour. So this is really showing that we were right in the past, and the improvements will continue. So now I will give a brief outlook and brief the situation. So with the learning curve, we always show that the watt peak learning is continuing, but nevertheless, we see that watt peak and this learning is not only a combination of efficiency learning and alone, but it has to be combined with the price, with per piece learning. Nevertheless, here over the past, this was, or last year especially, the overall prices increased. But this will now also continue, but we expect that this will stabilize over the next years. Nevertheless, we have to focus on efficiency learning in combination with really optimizing the cost. And with this challenge, so if we meet this challenge, so that we can continue this success of the PV industry. And for the last chart I will show is, so the outlook. So Michael, you mentioned here in Europe, and so we are now really boosting the PV installations. And over the years, we discussed in the ITRPV different scenarios. So we discussed here this really broad electrification scenario, and I expect and we expect that this is the most realistic. Nevertheless, in the past, so the IEA and the BNEF also showed some conservative approaches, and this year we got new figures. And here from IEA, so the expectation is for 2050, 0.8 terawatt. So I expect, so this is too low, too less. BNEF even expects here 1.1 terawatt peak market in 2050. So even this, I think it's quite conservative. So if we look here at the figures of the real shipments, so we are ahead of this expectation. And regarding the broad electrification, so there we are, even behind this target. So here to compare, so this is a BNEF scenario. It's quite conservative if you consider here this broad electrification. So what is important for the years to come? So the PV learning will continue. So this is quite a fact. And the 100 gigawatt markets are no problem at all. So they are now reality. And for the terawatt markets, so we will meet even with existing technologies this challenge, but there we have to do some more improvements really to not run into material shortages. And so this new technologies also, especially increasing the efficiency, will pave the way to this terawatt, and the ITRPV will provide also in future guidance to handle today's and future challenges. So, Michael, thank you very much for the possibility, and I want also to thank you all the contributors for the ITRPV. So, because your data are enabling this report, and everybody is welcome to join ITRPV. Thank you very much for your attention, and if you have any questions, please let me know. Thank you, Michael.
Thank you, Markus. I think, also once again from our side at TaiyangNews, I think you do a great service to the industry, and also please to everyone in the sector who can, please support Markus and his team. And it's simply very helpful what they are doing. Also, that they put in the end into perspective actually the different growth scenarios from IEA, which historically has been always way too conservative, but even Bloomberg, which is in the short term more on the optimistic side, is in the long run also rather pessimistic. If you Professor Breyer's modeling. So we had also one study at Solar Power Europe with them, and we also had in our scenarios in a 100% renewables scenario. I think if I recall correctly, we came up with over 7 terawatt of installed solar by 2040 or 2050 in Europe alone.
So this will be required. So, and we have not only to meet the challenge of providing here the modules, but we also need to install them. So this is the next challenge. So we discussed this yesterday as well, I think.
Permitting. least in Europe, I think the Commission has understood it. Okay, cool. Markus, I think in the chat there are some questions. If you could answer them there, we are running a little bit late due to.
Okay, so I will look in the chat and then try to answer. Yeah, so thank you very much and see you soon. Bye.